Yeah.
My
Okay.
parents were never so mad.
Okay. All right. So given the set of data 20, 15, 10, 20, 15, 10, 20, 20, 50, which statement best interprets the data? Only the mean is 20. Okay. How could we find out if that's true or
Add them
not?
all together.
Because the mode is 22.
Okay, but if it's what cannot be 20 if only the mean is 20?
The mode.
The mode, and the mode is the one that's the most. We got a 20, 20, 20, 20. 4 of them.
Yeah.
That's your mode, isn't it?
Mm-hmm.
Let's write that down. So the mode is 20. They're saying the mean is 20, but we may need to check that later. Okay, the range of the set of data is 20.
No.
What's the range?
The biggest minus the
So
40.
50 minus 10? 40? Okay. The mean, median, and mode are all 20. Well, let's look at median first. How do you find the median?
Add them up in numerical, or bump them up in numerical order.
From
Least to greatest.
least to greatest. Okay, so what's the smallest one?
10.
10, 15, 15, 20, 20, 20, 20.
4 20s. And then, okay, and there's 9 of them, so make sure you have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I like to mark them out from the ends. So what's the middle number? 20. So the mode is 20, the median is 20. How are we going to find the mean?
Add them all together and divide by 9.
And they told us it was 20, but you can't necessarily trust that. So we're going to add them all up and divide by 9 because there's 9 of them.
This is correct.
The mean is 20. So the mean, the median, and the mode are all 20. And just to be sure, the mode and the median are not the same. Well, they are the same. They're both 20, aren't they? So it can't be J. Has to be H. Okay, on these mean, median, and mode, you usually have to find each one of them and compare them. Okay, bless you. Okay, Miss Diaz asked each of her 27 statistics students to write down an integer from 1 to 10. To determine the most common number the students picked, which measure of central tendency should Miss Diaz use?
The mode.
Mode, because it means most, the one that occurs the most. Okay, measures of central tendency are mean, median, mode, and range. Okay, they mean when they say that. All right, Marcos has a spinner with 12 equal sections, colored either blue or red. If the spinner lands on blue on 33 out of 50 spins, which is most likely the number of blue sections on the spinner?
8.
Okay, how did you get 8?
I cross multiplied 33 and 12 and divided by 50.
Okay, did you set up a proportion?
Oh, yeah, I set up a
Okay.
proportion.
So what was your proportion?
33 over 50
Okay.
and x over 12.
So 33 blue spins out of 50 total spins would equal, we're looking for the blue sections, right? So that would be X, and then the total sections is 12. So it's just a simple proportion. These are total. This would be blue. Okay, so 33 times 12 divided by 50. You get 7.92, which is close to 8. Okay, and we knew it couldn't be 4 or 6. Why?
Because that's too little.
Yeah, because it's less than half, isn't it? The 33 out of 50 is a little bit more than half. What's half of 50?
25.
25. So it'd have to be more than half, and 6 is half, and 4 is too small. Okay.
10's too big.
So it is, but you still would need to check those two, the 8 and the 10, make sure which one's right. Okay, this is probability. Okay, probability is the top number is what you're looking for, the bottom number is the total number of possibilities. Okay. Okay, Jerry has a CD case that contains 4 country music CDs, 1 rock and roll CD, and 2 rap CDs, and 3 Tejano CDs. What is the probability of Jerry randomly selecting a Tejano CD and then, without replacing it, randomly selecting a rap CD from his case? So let's just start with his first pick. Okay, what's the probability that he will pick a Tejano CD? Well, how many Tejano CDs are there?
3.
Okay, out of the total number of CDs, 10. The bottom's always your total. Okay. Okay, now we assume that he actually did get a Tejano CD. Okay, and he didn't put it back. So how many CDs are left? 9. What's the probability that he'll get a rap CD? How many rap CDs are left? 2. Okay, so what do you do with these 2?
And 1.
Nope.
Multiply.
Yeah. Always multiply. You multiply the fractions together. So you're multiplying straight across. Okay, probability. You multiply them every time, okay? What's 3 times 2? 6. 10 times 9 is 90, and then you can reduce it, or you can do it really fast on your calculator. 6 divided by 90. Then what do? Math, enter. Math, fraction, enter. Okay, does everybody know how to do math, fraction, enter? Because that is a very helpful tool on your tax test. Use it on everything. Okay? 1/15. Or you can even put the whole thing in. You can do parentheses 3 divided by 10 times parentheses 2 divided by 9, and then change it math, enter. Okay. What if you didn't replace? What if you did replace it? How would it change?
Go back to 2/10.
It would be 2/10, wouldn't it? Because you'd still have 2 rap CDs left, but you'd have all 10 CDs. Okay. Everybody okay with that? Do you have a question? Sure. Okay. All right. Next one. This is probability again. A jar contains 6 red marbles and 10 blue marbles, all of equal size. If they're not equal size, then you're more likely to draw one than another one. So that's why they're all equal size. If Dominic were to randomly select one marble without replacement and then select another marble from the jar, what would be the probability of selecting 2 red marbles from the jar? So the first time he chooses, he wants to select a red marble. And the second time he chooses, he wants to select a red marble. Okay? So first time, what's the probability he'll get a red marble?
6 out of 16.
6 red out of 16 total. Okay. Now the next time he doesn't put it back. So what do we assume that he gets? A red marble. He doesn't put it back. So how many red marbles are left? 5 out of 15 red. 5 red out of 15 total. So what do you do with these 2 fractions? Multiply them. Okay.
30 over 2 and 40.
6 times 5 is 30. 16 times 15.
40.
Okay. Then reduce it.
1/8.
Yep. 30 will go into 248 times, won't it? Okay. Or you can just put in 6/16 times 5/15 in your calculator. Get it that way. Okay. Questions? Okay. This is about experimental probability and theoretical probability. Okay, experimental probability is when you actually roll the dice a bunch of times or whatever it is you're doing, spin the spinner, and you get some data. Okay. Theoretical is when you say, I think if I rolled the dice one time, what would happen? Okay. So we're going to look at this one. It says the table below shows the results of rolling a fair number cube. Okay, what does that mean?
Even chance to get
Huh? Go ahead.
It's an even chance to get each number.
Okay, yeah, it's an equal chance to get each number. Exactly right. Y'all ever heard of, first of all, what's a number cube anyway? It's a die. They don't use the word die because then it would be gambling. Okay, and they can't have gambling on the tax test. So they use number cubes.
Really?
Yeah, really. And they don't use, like, a deck of cards. Like, what's the probability of getting a heart in a deck out of a 52-card deck or something? They don't do that because of gambling, too. So, they use number cubes.
That's so weird.
Okay, and y'all heard of a loaded die?
Mhm.
Yeah.
And what does that mean?
There's a tree.
It's rigged how?
It's like it
No
has
claws
that-
take away.
It's weighted
It's
so
weighted.
that the 6 will.
Or what, yeah, want something in particular will come up more than the others. So that's why they're saying fair. It's not a loaded die, it's equal, like he said, equal chance of every number coming up, okay? And they rolled it 50 times during a classroom activity, and this is what happened. What does this mean? Outcome 1, frequency 7.
Means it's a.
It rolled the 1 7 times.
Yes, you got, when it rolled, you got a 1 7 times, you got a 2 how many times? 12, and a 3, 10, a 4, 9, and 5. What would you expect all these to be? The same, okay? But obviously, when you actually do it, it didn't turn out quite like you had expected. You expect them all to be equal. Okay, now it says, what is the difference between the theoretical probability of rolling a number less than 4 and the experimental results recorded in the table above? So let's label experimental and theoretical. Let's just start with experimental. Experimental will be the table, okay, what you actually rolled. And we want the probability of rolling a number less than 4. So what are the numbers less than 4?
20, 30,
1, 2,
Okay, and so how many times did we get a number less than 4?
29.
29 times, okay. Out of how many total rolls? 50. Okay. If you added all these up, you would get 50. Okay. Now, theoretically, if you roll a die, what's the probability you're going to get a number less than 4?
3 out of 6.
3 out of 6. There's the number 1, the number 2, and the number 3. That's 3 of them out of 6 possibilities on a die.
So you just cross multiply that.
No, what is it? What's the question asking?
Just the difference.
What does difference mean?
Subtract.
Okay, so this is the one time where we don't multiply. Okay. We're going to subtract these, and you can just subtract them on your calculator because otherwise you're going to have to get a common denominator. You can't just go 29 minus 3 and 50 minus 6.
Could you turn them into percents and then?
Yeah. You can. But you can do 29, parentheses, 29 divided by 50 minus parentheses, 3 divided by 6. 0.08, and that would be what percent?
8%. I, at first when I did this problem, I did it just for 4, and I did 1/6 is equal to 9 over 50, and then I cross multiplied them, and I got 92%, and then I just subtracted that, and I got 8. Is that just coincidental, or coincidence? Whatever.
It is. It is coincidental.
Okay.
It is. You're lucky. Okay, because you're not cross multiplying. When you say cross multiplying, you mean multiplying across?
No, I meant like I multiplied 50 times the 1 on top of the 1/6,
Oh.
and then 6 times the 9.
No. Okay. Yeah, don't do that in probability anyway, unless you're doing like a proportion like that spinner
Yeah.
one. Okay, yeah, I think you were just lucky. Okay. Okay. Any other questions on that one? That was kind of one of the harder probability problems, comparing experimental and theoretical. Okay. All right, number 7, the table below shows the number of student absences from the school year in Mr. Cruz's math class. Okay, so it says 0 days absent, 73 students. What does that mean?
That's
Yeah, 73. Oh no, that many people have 0 absence.
Right, 73 of his students had 0 absences, and then 55 of his students had 1 absent. Okay, could you figure out how many students he had?
143.
Okay, you add them all up, 143.
You have to do it.
Well, it's going to help you like with F, because we got to see, well, maybe not. We may not have to. It says, which of the following graph best represents the data shown in the table? What do you know about 3 and more than 3 up here? Well, what do you know about
2 and 1.
2 and more than 3?
Well, the same size.
They're the same size. So are they the same size here? Yeah,
Oh, yeah.
they pretty much are. And 3 is smaller, about half the size, right? Okay, so we're gonna look at these two.
But 0 is smaller
Zero
than 1.
has to be bigger.
Yeah, 0 has to be bigger.
0 needs to be larger than 1, doesn't it?
It has to be more than half.
And it does have to be more than half. How do you know that?
Cause
73 out of 143. Right, it's just a little more than half, but, so it's not that one. Okay, let's see what about H? They have 3 and more than 3 being the same. Are they supposed to be the
No.
same? No. Okay, so that's what's wrong with this one. 3 and more than 3 should not be the same. Okay, this one has 2 and 3 being the same. What's supposed to be the same? 2 and more than 3. Okay, so it's got to be J. We've got 2 and more than 3 are the same. 3 looks about half as much as those. Okay, the 0 absences are larger than the 1 absence. So J looks good. So we really didn't have to figure out that there were 143 students, but you could. Okay, the table below shows the population and the area in square miles of some U.S. states. Which statement best describes the relationship between the population and the area of the state?
B.
Okay, you like B? Okay.
Yes.
Right, what's wrong with A? The larger.
Alaska is pretty big, you know.
Yeah,
Oh.
New Jersey's the smallest one.
Yeah.
Let's say
Bigger.
So Alaska has large area but small population, and New Jersey has small area but large population. So that doesn't work, does it? How about New Jersey has the smallest population of the states in the table? No. Okay. Texas is the largest U.S. state,
It was before we got Alaska.
but it's not anymore, is it? You wouldn't believe how many people picked this last one. Okay. Be careful.
Right, they could just look at the chart.
Well, they don't look at the chart. They go, oh yeah, Texas is the largest U.S. state. Okay, so you gotta be careful. Look at the chart.
It's like the largest pond.